You know, one of the advantages of kind of these cloud-based services, such as ours, Link Live, is that you have a centralized repository for lots of information, and so we've been gathering data for about 18 months, and we wanted to present that. So if you look at our website in the banner, it's Wi-Fi Tech Today, and you can go and look at this stuff for yourself, and you can actually register and be able to look at the graphs interactively and all that. So I'm just going to show you kind of a slice of some of our findings. So just so you know, we have this AirMapper ecosystem. We have two products, AirCheck and Etherscope, that can, besides all their troubleshooting capability, about 18 months ago, we added the ability to do site surveys. They're basically the collectors. And then for analysis, you can either analyze it in Link Live, our cloud service, or in AMM Survey Pro. So it's been about 18 months, as I said. We've just done a set of continuous improvements, right? We have a new release every 6 weeks or so, and just kind of keep adding capabilities. In fact, the most recent we added is this ability to share, which is that you can take anything you have in Link Live, test results, captures, surveys, and share them with anybody. And they don't need to have a Link Live account. They don't need to pay anything. Our collaboration is one of our main mantras. And so the ability for people to share, because you might do a site survey and you just share it with the property owner, with the neighbors to show them how bad they are, or whatever, right? And in fact, I like to think that we've driven some of the unlicensing in the industry in the last 6 months to a year. So let me talk about the methodology, right? This is all anonymized data. We didn't look at anybody's individual accounts or anything. It was gathered between the time that we introduced our AirMapper in 2020 and early December. It's significantly significant, right? We're well into 5 digits worth of surveys and over 500,000 unique BSSIDs represented from around the world. We also scrubbed out, before we did this, all of our own information. Anybody with NetAlly or any of that stuff, right? None of our testing or product verification was used in this. And as we broke down the information, we broke it down by site. In other words, in the survey of the entire site, we saw these things. And we also broke it down by band in a lot of cases to make the percentages relevant. And then we broke it down by percentage of BSSIDs. So let's talk about 2.4 gig, right? The 2.4 gig cesspool, as hopefully you'll come to think of it as I think of it. It starts out pretty simple, right? You have channel assignments, and it's kind of what you'd expect. Channel 1 is just sort of the default channel. A lot of gear ends up there. And then you're kind of looking at these 3-4%, dabblers that shouldn't be running between 2 and 5 and 7 and 10 that you wouldn't think would be that significant. But then when you look at them on a per site basis, right, they're basically showing up on 30% of our surveys. We have literally an AP on every channel showing up. Right, so there's just a lot going on, a lot of poor channel assignments that are happening here. And if you think about which causes adjacent channel interference. Now, if you think about adjacent channel interference, it's not only the channel assignment, but also the channel width of the BSSID, right? And so, again, you kind of look at this, and basically 5% of the BSSIDs that we've seen, unique BSSIDs, and also I should say we group them by AP, right? So we're not multiple counting them. But about 5% are on 40 megahertz. Again, doesn't sound that bad. But then when you start to look at what's really happening here, and I'll take, this is a survey one of our sales guys did, and this is looking at adjacent channel interference with a threshold of minus 75 dB and the 2.4 gig band. And then this is the number of APs that are being impacted, right? And so it's a heat map, and kind of if I pick the kind of a worse spot in here, you know, in the 40 to 50 range and all that, you can see that it's basically, like here's an AP. In fact, this is double offensive, right? To not only be on not 1, 6, or 11, but then to also be 40 megahertz wide means that this one BSSID is trashing out 54 other legitimate APs, right? I mean, it's just, you know, it's not good. And so, and if you look at them, so this guy on channel 5, you know, he's taking out all the normal, you know, proper people, right? On channel 1, channel 6, 20 megahertz wide, you know, what you'd expect there. All these people are being impacted by these APs with poor channel assignments. So the 2.4 gig band is just kind of out of control. We added a feature recently to the surveys where we'd identify these offending BSSIDs. Because rather than having to go through the survey and look at every point in the survey and say, oh, what's it like where, what's it like there, we decided, okay, let's go across the entire survey, and with a set of criteria that you set, hey, I don't want to allow 40 megahertz, 80 megahertz, I don't want to allow these security types, I want at least this base rate, I don't want overlapping channels. We just basically, on the same survey, you can just see the number of BSSIDs that are on improper channels, 9, 4, 7, and 40 megahertz wide. And since I said, hey, don't allow WPA personal, original, not WPA2, you can see here's even another BSSID. So we kind of have not only the surveys and the heat maps and the ways of analyzing that, but also this ability to just sort of call out, hey, here's the guys that are impacting your survey. And we call that Insights, is the name of that feature in Link Live. So at the end of the day, you know, basically 83% of the sites, there's very few sites that don't have adjacent channel interference. Basically, you know, 18%, 17% of the sites were clean in terms of ACI, and everybody else had adjacent channel interference, right? So it's just prevalent, right? And so so you kind of look at that, let me go back for a second, and you say, boy, what hope is there for the 2.4 gig band? But the story's even worse, right? So not only do you have all of the adjacent channel interference, not only do you have all the layer 1 physical layer interference from, you know, Bluetooth and Zigbee and other things that are running in that unlicensed band, but you have beacon overhead, right? So here's an AP. They're putting out, you know, beacon takes about so it's supposed to come out every 102 milliseconds, and a beacon from a 2.4 gig typical size beacon, you know, ends up taking about a millisecond of airtime. So here now we're looking at, so this is another one of our heat charts. This is something we added about 4 or 5 months ago, which is you can look at the beacon overhead. Again, only it has to be above minus 75 dB, and here I'm looking at channel 11, and you know, this is 37% of the airtime is just taken up by beacons in this survey. And you can see it here, right? Here's the guys on channel 11, and the minimum basic rate, they're all running 1 megabit, right? So they're just sitting there slowly beaconing out, you know, all these APs. So it just, you know, between, you know, you kind of sit there and go, okay, you got the layer 1 physical noise, then you got all the bad channel assignments and adjacent channel interference, then you got 30% of your airtime being chewed up just by beacons. I mean, there just seems like there's no hope for the 2.4 gig band. So kind of interesting to see here. Here's another part of our insights analysis is you can set a threshold. Let's say I say I don't want more than 15% beacon overhead, and then we'll automatically show you the channels, no surprise, right? 1, 6, and 11. There's our 38% on channel 11, 25% on channel 6, 35% on channel 1. So, and I tell you, this isn't that unique. I mean, I've seen this in multi-dwelling, in retail, in hospitality. I mean, just everywhere. And of course, it's getting worse with people propping up hotspots and things like that. So So 2.4 gig band, not good. In fact, I was just in the hotel room, this is yesterday afternoon, turned on my Etherscope, let it run for, I don't know, 20, 30 minutes, looked over, and I had a bunch of, BSSIDs that we were picking up as a problem. And it's the ruckuses here, and they're just thrashing between channels. They're just sitting there, because all the vendors have their smart air, radio resource management, clean air, whatever you want to call it, right? But it's basically their version of artificial intelligence that's going to sit there and pick the right channels for you. And so, in a lot of cases, and I've seen this with all vendors, right? I'm not calling out ruckus here, but basically they're just sitting there changing channels every whatever their cadence is for analyzing the air and flipping around. And then with that, of course, they got to bring all the clients with them, right? So it's so that's sort of the resulting problem. And so that's the 2.4 gig story in terms of channel assignments. Let's switch to 5 gig. It's a little bit better. So here's our data at the top, and then I took the WLPC chart, sort of overlaid it and aligned it channel-wise, so you can see where the DFS is and all that. And what you see is 36 is most prevalent. That's probably because most equipment out of the box would be set on channel 36, right? And so if you didn't change the channel, then that's where you'd sit, and that's in fact what we're seeing. And then you kind of see this phenomena where I think a lot of things run 40 megahertz, so they take out 36, 40, and then 44 becomes the next most popular channel. And you kind of see that same pattern, high, low, high, over here as you get above the DFS channels. It's more channels to spread out in. However, and then really this it's pretty. Basically, what you're seeing on a per BSSID basis is what you're seeing on a side basis. So this is the percentage of sites print kind of matches the percentage of BSSID prints. But there's still adjacent channel interference in the 5 gig band. And the reality is it's only basically 9% better. So the percentage of sites where we have no ACI, zero ACI in the 2.4 gig, because the 2.4 gig then is all spread out here, right? The number of interferers. It's only slightly better and skewed lower, as you can see, in the 5 gig band, but still a thing, right? There's still a lot of basically 65% of sites have adjacent channel interference in the 5 gig band, is what this would tell you. So channel widths are a big part of that, right? And so because a lot of things are still, if you look at it, in fact, you have almost an equal balance of sites, a little bit more than 20 megahertz wide, 5 gig channels, but there's plenty of 40 megahertz and 80 megahertz wide channels that are BSSIDs, APs running in the 5 gig band. So, and kind of what's happening here is, so if we take this particular BSSID, this particular SSID, and it's 80 megahertz wide and it's on channel 153 as the primary channel, that means it's basically taking out, it's basically from 149 to 161 and basically interfering with all these guys on 149, 157, 161. And so here's a guy running 80 megahertz wide interfering with 17 other APs, even though it's in the 5 gig band, right? So it just sort of speaks to that it's better, but not much better. I mean, I think really the primary hope here is going to be for the 6 gig band and the clean air that happens there. So let's see, number of APs that can hear other APs on the same channel. This is co-channel interference, right? So we talked about adjacent channel interference, which is the worst interference. Of course, there's still co-channel interference where the APs are cooperating and all that. We still basically, again, you can sort of see it skewed, right? Any AP at any location being able to hear multiple APs is skewed lower, right, in the 5 gig band because there's less, because there's better channel assignments and things like that, more unique channels to run on. And then as you kind of look out here, you just end up picking up the 2.4 gig band just becomes dominant, right? And it's not uncommon at any surveys to see 10, 15, 20 APs that you can see on any given channel, in terms of co-channel interference. Technology adoption. Interesting here, right? Basically, percentage of BSSIDs, there's still B, 5 gig, 802.11a only works in the 5 gig band, of course, and then G was only in 2.4. I think it wasn't until we got to N, 802.11n, that it was dual band, right? And then you can kind of see a reasonable balance there. AC. Back to 5 gig, and then AX. AX is kind of interesting, right? AX can run in 2.4 or 5 gig or 6 gig for that matter, right? We just don't have that data yet, but it's kind of interesting because again, this is another one where when you look at the percentage of BSSIDs that are running, let's say Wi-Fi 6. It's relatively low. It's maybe 5%-ish. But then you kind of look at how many sites it's showing up on, and it's 30% of the sites, right? So there's a pretty, so there's some Wi-Fi 6 starting to happen out there. 30% of the sites in these surveys. And as we get more data over time, we're going to start to trend this over time, right? So we'll be able to see the adoption of these technologies in future WLPCs. So minimum basic rates, right? Basically the vast majority of 2.4 gig stuff is running at 1 megabit, right? Which kind of speaks to the beacon overhead that I was showing earlier, and the majority of 5 gig stuff kind of runs at the minimum basic rate that you can run in 5 gig, which is 6 megabits. So. And then you see, some folks that are picking up higher minimum basic rates. Security types, not much really showing up on WPA3 Enterprise. Seeing a little bit showing up on WPA3 Personal. I think that's largely because you're seeing residential APs, right? If you kind of look at what's out there, it seems like, as usual, the resi stuff is the first to bring new technologies in. And then still some kind of legacy, on at whatever 20-ish% of the sites. You're still seeing some Cisco fast transition security types. But again, the vast majority is WPA2 personal. So the conclusion is, we're just getting started, right? We're just starting to gather this data and look at it. The data set will only get stronger. I think what we want to start looking at is kind of some, two-dimensional analysis, right? Bubble charts, if you will. How does the security type plot again in terms of magnitude or numbers plot up against technology type or things like that? And then as I mentioned, we'll be able to start graphing this data over time. And then as we move forward, if anybody has any additional requests for graphs or has anything they're kind of curious about, just feel free to email me, right? And we'll see if we can't kind of figure out a way to mine the data and bring that information out. So that's all I have. I don't know if there's any questions or dialogue. Hopefully you found it interesting.
Any questions, anyone? Don't be shy about it.
Yeah, so if you go to let me go back here. If you go to our website, we have one of the banners is this Wi-Fi Tech Today. If you click on that, you can enter your email, and we'll give you access to the entire report. Yes.
That metric where you showed like over 30% of Wi-Fi 6 client devices, was that here?
No.
The capture, was that larger?
No. This is just in these I'll say tens of thousands of surveys. Yeah, that's the technology adoption. Right. So in terms of the number of BSSIDs that are Wi-Fi 6 AX, fairly low, right? You'd say 5%-ish, let's say. Well, I thought what was interesting to me, what surprised me was how much of it's in the 2.4 gig band, though, right? Well, like, why, after all this stuff I showed on 2.4, why would you even want to play there? So, it's kind of interesting that, and maybe that's just the default out-of-box behavior, which I think drives a lot of the industry. Yeah. So, but I mean, what this tells to me is fairly low in terms of the number of actual BSSIDs that are deploying Wi-Fi 6, but, about 30% of the times in a given site, you're going to encounter it, is kind of the takeaway of this chart. All right, any other questions?
Any other questions, anyone? Questions, jokes? Oh, we had a question here.
What are the two products right here that we're looking at up here in the front?
Can you get the first page? So you get something.
Yeah. So these are the. So these are our two collectors. Let me get back here. So this is the AirCheck G2. That's here. Small, thin, portable, handheld. And then the Etherscope, which includes lots of wireline capabilities, PoE loading, 10 gigabit throughput, capture, discovery, all those things. So those are sort of the two products. And like I said, we use them as kind of the portable handheld tool collectors. One of the interesting things we've done is as we've built them out, first we did passive survey, then we did active survey. Then we have a second radio in the box. So we also and it's a 1x1. It's a Qualcomm 1x1 radio. So it's a legitimate radio, but it sort of emulates the most important, least capable radio in your organization. So at the same time that you're doing a passive survey, you can be doing an active 1x1 survey and understand where your roam points are and how your coverage is there. And then we added Bluetooth BLE survey at the same time. So kind of this one walk, many collections. At the same time, you walk the site once. You get a passive survey. You can get an active 1x1. You can get a Bluetooth survey, and then at the same time, we're basically doing network discovery. Whatever SSID you connect to, we're going to go in and find all the devices, and actually we're going to correlate the MAC addresses we see in the air to the IP addresses we see through ARP sweeping and discovery techniques, and then you can do topology mapping with that, and then at the same time you're doing that, somebody remotely, like the expert, could be actually connected in either through our cloud service or VNC, and actually watching and sharing exactly what you're doing on the screen. So you can literally drop ship this to a location, tell them to walk around a bit. In fact, you can do floor plan management. One of the things we added about 5-6 months ago was floor plan management. So in Link Live, you can put your floor plan up there, calibrate it, and then choose which testers to push it down to. So we just continue to improve, as you can see, over the course of 18 months, just adding capability. And Insights was our most recent thing, along with this collaboration. QBSS, I didn't even touch on that. If you look at, it's kind of interesting when you look at the one more here. Let's see here. Let me go back one. Yeah. So when you look at these guys in terms of adjacent channel interference, they're sitting here running at 29%, 41%, 36% utilization, right? So they're actually, running fairly high in terms of. Let's see if I have another one of these. Let's see, minimum basic rate. Yeah, here's this guy. This is the guy. All right, so here's APs that are reporting 79%, 60%, 50% channel, which is basically saturated, right? You're not gonna get any airtime with that. So yeah, I mean the 2.4 gig band, I tell you, it's just amazing how many different ways it's impaired. And so, in fact, that'll be one of the things we'll do in the future maybe is sort of the state of utilization. Now, QBSS, as you saw earlier today, is sort of the AP telling you what it's seeing. And what's interesting is when I look at the QBSS channel client counts, it's not that high. You're seeing 3, 4, 5 clients associated to any one of these BSSIDs, but the utilization's up at 80%, and it's because of all the other airtime stuff that's going on and the beacon overhead and things like that. Because that is the AP's version of what's happening at layer 2 in terms of ability to get a clean channel or clear channels. So anyway, we've got a lot of data. We've got a lot of analysis coming up. Look for us in the future as we continue to mine this data. This is just sort of our first pass through. It's sort of a rudimentary, basic bar chart sort of analysis of how things are being assigned and channel plans and all that. But there's a lot more analysis that we have planned for the future. So.